Hello, calculus fans. Let's find a unit vector orthogonal to the plane containing these 3 points. So P is 1, 2, 3, Q is 0, -1, 5, and R is 1, -1, -1. In general, 3 points are enough to determine a plane, in the same way that 2 points are enough to determine a line. Now, 3 points don't always determine a plane. If the 3 points happen to lie in a straight line, then there are many different planes that contain those 3 points. All right, so we know that to get a vector that's orthogonal to 2 vectors, we have to cross them. And in this case, we're going to cross PQ and PR. And this is going to be orthogonal to the plane that contains P, Q, and R. All right, we'll compute PQ and PR. We just have to subtract the points to get these vectors. You should double check to make sure that we've got these vectors right. Notice I'm writing them in IJK notation. You should get used to either way of writing vectors. Now we'll get a vector orthogonal to the plane by crossing PQ and PR. If we do the cross product, we end up with 18i minus 4j plus 3k. You should double check to make sure that this is the correct cross product. Now we're not quite done because the question asked for a unit vector. So what we need to do is take this vector and scale it down to a unit vector. First we'll compute the length of this vector, which is the square root of 18 squared plus -4 squared plus 3 squared, and we get square root of 349. So, if we want a unit vector that's orthogonal to the plane, we'll take the vector that we just computed and divide everything by square root of 349. That'll scale it down to size. And so here's our final answer for a unit vector which is orthogonal to the plane determined by P, Q, and R. Okay, that's all for now.